Whenever you talk about carbonyl compounds, you're basically talking about aldehydes and ketones both. So you're talking about aldehydes as well as ketones and ketones. Aldehydes are the ones where you have C double bond O right at the end of the chain, and ketones are ones where you have C double bond O somewhere in the middle of the chain. So aldehyde and ketones. The first thing is about the physical properties. The physical properties are for both aldehydes and ketones. The physical property is that they kind of, I mean, they can't form hydrogen bonds, but they are polar molecules. They have a C double bond O group, and this group is polar because the carbon is partial positive and the oxygen over here is partial negative. So it has permanent dipoles. And since it has permanent dipoles, the melting and boiling points are higher than alkanes and alkenes. They are higher than alkanes and alkenes, but they are lower than alcohols or carboxylic acids. They can't. Alkanes and alkenes had van der Waals forces, like they were completely non-polar. Everyone has van der Waals forces, but alkanes and alkenes only have van der Waals forces. And alcohols and carboxylic acids, they are capable of forming hydrogen bonds. Similarly, the second point is aldehydes and ketones, carbonyl compounds are not very soluble in water because they can't form hydrogen bonds. I mean, the O is not directly bonded to H. Okay, Ibrahim, is this clear?
Yes, sir.
Now, the other part is let's talk about the reaction. They only have one main reaction. I mean, apart from oxidation reduction, uh, there is this nucleophilic addition reaction whose mechanism should be known. What happens in this reaction is that you have, remember, I'm talking about aldehyde and ketones both. So you might have, let's say you have a ketone. It reacts with an HCN molecule, and there is NaCN catalyst. And what happened is that the C that was making the double bond, that would change into a cyanohydrin. It would change into an OH would be bonded to it, and a CN is going to get bonded to that particular carbon atom. So this carbon atom that was initially uh, forming a double bond or a carbonyl group. So this is the reaction that's going to take place. Uh, and these are known as cyanohydrins. It's a class of compounds that it's kind of a nitrile and an alcohol at the same time. So this is the reaction, and you'll be asked about the mechanism of this reaction. We've written down the conditions. The mechanism of this reaction, nucleophilic addition reaction, is that you have R, C, and double bond O over here. The carbon has a partial positive charge, the oxygen has a partial negative charge. The Cn minus 1 nucleophile is strongly attracted to the positive carbon atom, and this is a nucleophile. And this Cn minus 1 initially comes from the initially produced by the catalyst, which is NaCN. Since HCN doesn't ionize readily, so HCN doesn't produce a lot of CNIons, so HCN doesn't ionize a lot. So the first few CNIons in the solution, they come from NaCN, which is why NaCN catalyst is required. Anyways, the Cn minus 1 attacks, uh, let me change this. Okay, so the Cn minus 1 nucleophile attacks the carbon positive, and the electrons over here in the double bond, they're going to get repelled. And the next step is that this intermediate is going to be produced, that it's going to have R, and then there's going to be C, and then there's another R. This thing over here would become O minus 1 because the electrons are getting repelled. Why? Because there was a Cn that was coming in to bond with it, a Cn minus 1 that was coming in to bond with this molecule. So, so this Cn minus 1 was coming in to bond with it. Next step is, okay, the next step is when this happens, the HCN molecule, which is polar, the H is positive and the Cn is partial negative, and it doesn't like to ionize, but because the negative oxygen is going to attract the H positive, the electrons over here are going to get repelled, and the HCN molecule is going to break off, and the result would be that it would become R, and there would be C in the middle, and another R, and there's going to be Cn, and an OH would be formed at the top, and the Cn minus 1 nucleophile is going to be reproduced, which is why it would be regenerated, which is why it's acting as a catalyst. So it would be reformed in the whole mechanism. So that's basically your nucleophilic addition mechanism. This is what you're going to draw if you're asked to draw this. Okay, is this clear? Aba, Hiba, Ibra, is this clear?
Yes.
So just remember that you're going to have a carbon that is positive in an aldehyde or a ketone, and the Cn minus 1 is going to attack it, and the oxygen over here, the electrons over here are going to get repelled. It would become oxygen minus 1 at the top, and the Cn would bond at the bottom. The oxygen minus 1 is going to take away one H from HCN, and it would form an alcohol, and Cn minus 1 would be regenerated in the sequence. So that's nucleophilic addition. That's about it. Okay, nothing more to this mechanism over here. Okay, then you have the next thing about aldehydes and ketones, that is 2,4-D and pH. It's a test for identifying carbonyl compounds. test for identifying carbonyl compounds. So the test is known as 2,4-DNPH. I mean, the thing that you add, the reagent that you add, that is known as 2,4-DNPH. Uh, the proper pronunciation for this is, I mean, this is an abbreviation, but you can write 2,4-DNPH. You can also write 2,4-dinitrophenyl hydrazine. Okay, that's the proper name of this molecule. And the observation, the conclusion would be for aldehyde and ketones, it's going to be an orange precipitate formed. That would be the result. Uh, this 2,4-DNPH could be, I mean, that's pretty much it. Whenever you want to identify a carbonyl compound, just write that to use 2,4-DNPH, which is a chemical, and an orange precipitate would be formed with carbonyl compounds. Now, very rarely anything else about this reaction is asked. In 20 years, only once have they asked about the whole reaction. So 2,4-DNPH. So I'm going to draw just on the safe side, I'm going to draw the whole reaction sequence that happens. Like if you have an aldehyde or a ketone, what happens is 2,4-DNPH is this thing. It is N with two H's, then there is another N with another H, then there is benzene. Okay, then there is a benzene structure, and then there are two NO2 at 2 and 4 positions. So this is 2,4-dinitrophenyl hydrazine. I mean, this is the molecule. This is known as 2,4-DNPH. A lot of times a compressed notation is written, so it's NH2, NH, followed by C6H5, followed by two NO2s. So a compressed notation is sometimes also written. The reaction that happens is it's known as a condensation reaction, that the O and the two hydrogens over here, they get removed. And as a result, the two molecules join up. So it's a condensation reaction. The two molecules are going to join up. And this is what's going to be produced. There's going to be RC double bond R. And over here, the N would lose its two hydrogens. And then you have this benzene with its and your NO2. And the two are going to join up. And a water molecule is produced as a byproduct. So very rarely have they asked for the reaction. So remember this C double bond O, the aldehyde and ketone group, it can react with a 2,4-DNPH molecule to form that, and that's your yellow precipitate that is formed, not a yellow-orange precipitate. The color actually varies from yellow to red, actually, but you can be, just to be on the safe side, you can write. Wait a second, what's happening? No idea where my molecule went. Just 1 second, quickly, let me. And then there is Okay, let me redraw this. And there was H. Okay, then something happened to the benzene, and there was definitely another NO2. Okay, why is there Y over here? Okay, that's pretty much it. No, I was trying to write orange precipitate. So that is your orange precipitate over here. So just remember, carbonyl compounds are 2,4-D-NPH. You get an orange precipitate. Very rarely will they ask you about this reaction. Okay, is this clear? Abba, is this clear? Hiba, is this clear?
Yes.
Okay, that's pretty much it all about aldehyde and ketones. One other thing that we have already done is, and I'm going to add over here, that once you know that it is a carbonyl compound, how would you differentiate between an aldehyde and a ketone? So
By
differentiate.
tolerance reagent.
ठीक है क्योंकि aldehydes they get oxidized. So you can use tolerance three. I mean there were three of them. ठीक है, which we had done. पता नहीं इधर ऊपर क्या था where aldehydes were getting oxidized and ketones were not. Somewhere over here. ठीक है, so aldehydes over here they were getting oxidized. Ketones were not getting oxidized. So aldehydes can be oxidized by four things: Fehling, tolerance, K2Cr27, or even KMNO4. All of them are going to work, and all of them are going to give you some sort of observation. So that's how you differentiate between aldehydes and ketones. So differentiate between aldehyde and ketones. The answer is aldehydes get oxidized. So it's K2Cr27, toluenes, or your Fehling reagent. And ketones don't. So that's it. Then we're going to talk about another test which is known as the Iro Foam Test. So let's talk about the Ido Form Test. Now the Ido Form Test is we're done with aldehyde and ketones. The Ido Form Test. The Ido Form Test is a test for identifying a very specific structure. It doesn't identify a functional group. It identifies a very specific structure. A very specific structure. And the structure is this one. There is CH3, C double bond O, and here's the rest of the molecule. So that is one structure that could be identified using the iodoform test. And it has to be specifically this structure. It has to be a CH3, which should be next to a serial bond O. Or it could be this one. It could be CH3, C next to an OH, R group, and there is H. Only these two structures would be identified. In both cases, what happens is that if you do the iodoform test, the CH3 breaks off. And in both cases, it forms a CHI3, which is a yellow precipitate. So you get a yellow precipitate. And in both cases, this other side, especially this carbon, in both cases, the one that was with OH or the one that's with a with an alcohol, they get oxidized to form a carboxylic acid. So the carbon over there will get oxidized to form a carboxylic acid. The conditions for the iodoform test is that it's alkaline aqueous iodine, which is NaOH aqueous, plus I2. So those are the conditions for the reaction. You need alkaline aqueous, iodine, and this is going to happen. But since the conditions are alkaline, you'll get a salt of the carboxylic acid instead of getting the carboxylic acid because the conditions are alkaline. So under alkaline conditions, you don't get the carboxylic acid. So remember this particular test, it's about a very specific structure that it has to be CH3. I mean, there has to even if a molecule has CH2, then this test would not happen. It's got to be a CH3, and the CH3 should be next to a serial bond O, or it has to be a CH3 which is next to COH, and the COH should also have an H with it. Otherwise, this test would not be possible. So that's an Iodoform test. It's another small little test. Uh,
Sir, if someone, can you repeat the initial part of it? Okay, starting में क्या होता है?
these it's simply the CH3 breaks off. Uh, For, for example,
अच्छा.
for example, you have butyl 2-ol. So butyl 2-ol is what? Four carbon atoms, and there's an OH over here.
Yes.
अच्छा पहले बताओ कि will it give a positive test or not for iodoform
मतलब when do we get a positive test for this?
when you have this specific structure in the molecule?
A CH3?
A CH3 next to COH and H. So I mean,
Yes. जी. और
ठीक है, you need this thing for the iodoform test to be positive. Do you have that in this molecule?
yes. जी जी.
ठीक है, so you have that. You have a CH3 next to a COH and H. Achha, what's going to happen when you add alkaline aqueous iodine? The molecule is going to break over here at this point. This part would form CHI3, which is going to be a yellow precipitate. And this other part would change into a carboxylic acid. I mean, it's going to be CH3, and then there's going to be serial bond O and OH. Instead, it's going to be a salt because you're using alkaline conditions. Ibra, is this clear?
Yes, जी समझ आ रहा.
I said again, if the OH was at any other point, like OH was over here, then the iodoform test would not have been positive. Okay? It has to be a CH3 next to this kind of thing. Or the first one, which is it has to be a CH3, which should be next to serial bond O. Okay? It has to be that way. Just 1 second. अच्छा अगला part. Okay, let's go. Let's try and complete this. Okay, that's the iodoform test. Now, for carboxylic acids, we have pretty much done most of the things. What is only needed is the formation of carboxylic acids. Remember, carboxylic acids, not much is in your course. I said we've already studied a lot of things about carboxylic acids, their reduction and their oxidation. Sorry, I said their oxidation and reduction both have been already taught. Uh, we've also learned about esterification, which involved carboxylic acid, so that's also done. So what's only left is there's one formation method, which is, I mean, one way to form is through oxidation, which we have already studied. Oxidation of primary alcohols and aldehydes. The second is hydrolysis of nitriles. So we're just going to study hydrolysis of nitriles because we've done the first one. The reaction is simple. That you have RC triple bond N, a nitrile, and you heat it with dilute acid or alkali. Or alkali. So dilute acid, or you can add an alkali to it. And the molecule is going to hydrolyze. It would react with, there's going to be hydrolysis, and it would simply change into, just remember it's going to change into carboxylic acid. That's pretty much it. So that's probably the only reaction that was left. So we are done with we're done with all carboxylic acid reactions and all organic reactions. What we can do in the next class is we can try and figure out, we can make a spider chart so that it's easier for us to remember all these reactions and all these conditions, and we can sort of link them up into a spider chart that would help us in remembering all these reactions. Okay? So we did Iro Foam Test, and we did aldehyde and ketones, the identification of two aldehyde and ketones with 2,4-D and pH. We talked about nucleophilic addition reactions of aldehyde and ketones. So try going through. As I think now it's. Patani, I don't know if the screen was shared or not. But this is the hydrolysis. So this is the last thing, hydrolysis of nitriles. So next class में we'll learn how to sort of remember all of them, all of the reactions that we've just studied. Okay? So just try and remember this is all the detail that's there. Uh, and now we're going to try and simplify this so that it's easier for us to remember everything about organic chemistry. Okay? And how to link them up and associate them with each other. So, ठीक है, we'll do that in the next class then, ठीक है?
चल ठीक है सर, अल्लाह हाफिज़ सर, थैंक यू.
Okay, take care. Allah.